here, that half reflects over to there. But again, there's the graph of f of x and f inverse of x. Any questions? Okay, so let's talk about temperature conversion. So, like, what is the what's the formula for Celsius as a function of Fahrenheit? So, let's let D equal degrees Fahrenheit, okay? So we should have something like some m times d plus b, right? It's like it's a linear function. Can you figure out what these values have to be? Let's think through it. What's that?
C times or C times 5, 9 plus 32.
Let's see here. Oh, yeah, I'm sorry. I just a second. Let me not try to work it out. I mean, you could figure it out from boiling and from freezing, but let me just be lazier. I did take a... Yeah, exactly. So here's the degrees Fahrenheit, right, are equal to the degrees, well, 9/5 degrees Celsius, all right, plus 32. So let me write this a different way. Let's say that I mean, that's fine. So what I'm looking at here, right? If I let's say let x equal to degrees Celsius and y equal to degrees Fahrenheit, just for the sake of discussion, right? So the original equation we can think of as y equals f of x, right? Where f of x is what? 9/5 x plus 32, right? How do I find the inverse function? Solve for x, right? If I solve for x here, I get y minus 32 is 9/5 x, which gives me x is 5/9 times y minus 32. So f inverse of y is 5/9 times y minus 32. And that tells me how to convert what? To convert Fahrenheit to Celsius, right? For example, if I have 32 Fahrenheit, how many Celsius? Well, 0 Celsius, right? 32 minus 32 is 0. If I have 212 degrees Fahrenheit, what do I get? Five ninths of 212 minus 32, which is what? 5/9 of 180, which is 5 times 20, which is 100, right? Because this is how the Fahrenheit scale is set, well, how the Celsius scale is set up, rather, is to make 100 degrees Celsius boiling water, right? Whereas in Fahrenheit, for reasons I don't remember, the boiling is 212 degrees Fahrenheit, right? How is the Fahrenheit scale defined? Freezing? Well, 32 degrees is freezing for Fahrenheit. I mean, it's whatever the historical basis for the Fahrenheit, scale. It's not so elegant and, physical as like the Celsius scale, right? I mean, Celsius has 0 is freezing and 100 is boiling. That's pretty nice, right? But on the other hand, it's annoying because when people talk about like temperature in terms of Celsius, it's far more like, well, you see how it goes. It's a pretentious form of measurement, perhaps, but there's no Europeans here, right? Okay, so you know, what do you have? How many degrees Celsius corresponds to? You know, a change, one degree Celsius change is 9/5, right? 1.8 degrees Fahrenheit change, right? So if you're talking about a 10-degree change in Celsius, you're talking about 18 degrees change in Fahrenheit. So like Fahrenheit is just a finer scale. So you can communicate smaller differences in temperatures more naturally without using decimal points. Like Celsius is much more, you know, 10 degrees Celsius is a much bigger jump in temperature than 10 degrees Fahrenheit. When are they equal? How would you figure that out? What you would do is you would set, where is f of x equal to f inverse of x here, right? And that would be 9/5 x plus 32 equals to 5/9 x minus 32. Solve this equation. Those are lines. They don't have the same slope. They do have to cross somewhere. Yeah.
I'm saying that's when they hit, right?
Oh yeah, that's when they intersect, right? So if I do, what do I do here? Multiply by 45, I guess. What's that give me? It gives me 81x plus 32 times 45 equals to 25x minus 25 times 32. If I subtract, then I get 21, 50, oh man, 56x? Minus 25, minus, good grief, minus 32 times 45, come on. Minus 25 times 32, so apparently x is equal to, oh, what's 45 and 25 is 50, 70. So apparently minus 70 times 32 divided by 56. I don't know, what's that? About minus 40? Is it approximately minus 40 or is it exactly minus 40? Oh yeah, because that, I see it. Because 56 is 7 times 8. So the 7 cancels the 7 to give you 10, and the 8 cancels the 32 to give you 4. So yeah, minus 40. So there you go. The Celsius and Fahrenheit scale do agree on one temperature, negative 40. So negative 40 Celsius is equal to negative 40 Fahrenheit. Okay, so what's the moral of my story here? It's just this. If you use different letters for different variables, it can matter when you're talking about different things, right? Like degrees Fahrenheit versus degrees Celsius. See, if I use X for both, it starts to be hard to understand. Unless you're asking this like perverse question about where they're equal, you know. But anyway, okay, enough about that. I'm surprised that example's not in your book. It's in most books. I don't know why it's not in your book. All right. Let's do another one. Suppose we want to find the formula for f inverse. Let's do something with a cube. So this was example 8. Example 9. you got f of x equal to the cube root of 3x minus 7. Take my word for it. This is a one-to-one function. All right? Let's find its inverse. How should we do it? We write y equals to the cube root of 3x minus 7. Step number 1. It's a simple step, but it is a necessary step in this algorithm, all right? Step number 2, solve for x. How do you solve for x here? Any suggestions? I like it, cube it. So y cubed, the cube root, 3x minus 7 cube. So the cube is the natural enemy of the cube root. So you get 3x minus 7. Wonderful. Divide both sides by 0. Huh. Don't make me angry. You won't like me. You won't like me. It's here. So 3x is equal to y cubed plus 7. And then divide by 3, not 0. Y cubed plus 7. I mean, there are worse things than dividing by 0. I had a student about, I don't know, 5, 6 years ago who wanted to use 7 as a variable. I'd be like, I can't think of a letter. Can you think of another variable name here? He'd be like 7. Like, no, we are not using 7 as a variable. Stop that. So then he went to live in Australia, so the joke's on him. But anyway. Well, I used to think of Australia as this like place of freedom and, you know, rugged individualism. But then I watched the news the last 3 years.
Literally everything.
Good grief. What's that?
Literally everything in Australia. That's about right.
Including the police, yes. So, f inverse of y is equal to 1/3 of, I mean, they're like tracking people going to see their friend. Like their COVID hysteria was next level. Anyway. And of course they still all got it. Got to give credit where credit's due. It was a good bioweapon. But anyway. This is sufficiently far into a YouTube video that it shouldn't get noticed. Let's see here. If I get a COVID information banner when I post this, I'm impressed. No, that's just one of you. That would just be one of you reporting it. That's like the only way that's going to happen. But so there it is. This is the inverse function. Now, if you wanted to write it in terms of x, what would you do? No, just, well, you could do that, but just basically all you do is just put x there instead of y, just that. It's really not an interesting step. You just switch y to x, and there you go. That's the f inverse of x right there. One final question. What's the domain and range of this function? Yep.
They should be all positive.
Oh no, cube root can be negative. Cube root of a negative number is a negative number again. So in fact, I'll tell you the answer here is that the domain and the range are all reals. And you know what? The domain and the range of this are also all reals. So you can't see much of that. We'll talk more about domain and range. There's something sneaky we can do there. But we'll get to it next time. Anyway, thanks guys. Let me turn off the camera here before I forget. You liking and subscribing.